So, good morning, friends. Welcome to the Hydraulics and Hydraulic Machines course. In today's lecture, we focus on some more problems related to a single moving plate or vane. In the last two lectures, if you see, in the first lecture, we have solved problems related to a fixed plate. What is the force exerted by the jet on the plate if the plate is kept vertical, if the plate is kept inclined, if the plate is a curved plate, which we call it as vane. So, on these three topics, we have solved problems. In the second lecture of problems, we solved instead of a fixed plate, if the plate is hinged at the top, what is the angle of inclination, what is the force, what is the force to be applied in the opposite direction to keep the plate vertical. So these problems we solve in the problems lecture 2. Now in third lecture we solve the problems related to a single plate or a single vane moving instead of fixed. Now it is moving plate, moving vertical plate, moving inclined plate, moving curved plate. So these three problems now in this lecture we will complete. So this lecture focus is on the problems related to single moving plate or vane. So this is what the topic is. Let us recollect once again. For example, a single flat plate kept vertically moving, if you take it, what is F is equal to rho A into V minus U whole square, where rho is mass density, A is area of the plate, V is the velocity of jet, U is velocity of plate. The moment plate is moving, the next thing in this will come is what is work done. If the plate is fixed, work done is equal to 0. If the plate is moving, the work done will come into picture. It is Fx into velocity of the plate. Then once work done is known, then people will ask what is efficiency. Efficiency is equal to output by input, which is equal to output is nothing but the work done basically per second divided by input is nothing but the kinetic energy of jet leaving the nozzle. So it is work done by half into mv square. So it is nothing but work done per second, which is nothing but Fx into U divided by Kinetic energy is half into rho A V into V square. So this you put it, you will get that. Suppose if I take case 2, an inclined plate moving. If that is the case, how the problem change? In such a case, we find always Fn. Fn is equal to rho A into V minus U whole square into sine theta. This is the first thing. So therefore, Fx is equal to Fn sine theta and Fy is equal to Fn cos theta. All this we have done previously. So therefore, Fx is equal to rho A into V minus U whole square into sine square theta. Fy is equal to rho A into V minus U whole square into sine theta cos theta. Right? Next. Afterwards, what is work done? Work done is equal to Fx into U. And then what is the efficiency? It is nothing but output by input. Input is always kinetic energy of jet. So Fx into U divided by half into rho AV into V square. So this is the second one. What is the third one actually? Single curved plate moving. This is the third. So if I take this jet striking at center, so these are the three we will take up today the problems. So if such a case, if you remember once again, recollect. So this is the vane actually. Jet is striking at the center like this and it is leaving like this. The plate is moving in this direction. If this is V, this is U and it is leaving like this actually. So this angle is for us theta. This is U. So deflection angle is this is 180 minus theta, which we call it as deflection angle. So it gives like this, right? This is the problem. So in such a case, what is Fx is equal to? Fx is equal to rho A into V minus U whole square, sorry, into 1 plus cos theta. This already I have solved. Then what is work done is equal to Fx into U. What is efficiency is equal to work done divided by kinetic energy of jet. So these three problems only today we will solve in this lecture. If the jet is striking at one end and leaving the other end, in the next class we solve the problems. So I think you got clarity on which I am going to solve the problems. So let us take our first problem of today's lecture. A nozzle of 50 mm diameter delivers a stream of water at 20 meters square, 20 meters per second, perpendicular to the plate that moves away from the jet at 5 meters per second. Find the force on the plate, the work done, the efficiency. Object. These are the three. So let us take it. What is the given thing? I will take it. Solution. If the solution I take it, diameter of the jet D is equal to, they have given 50 mm. So it is 50 into 10 to the power of minus 3 meters. Then what is area of jet A is equal to pi by 4 into d square. So it is pi by 4 into 50 into 10 to the power of minus 3 whole square. So this works out to be 0.001963 meters square. Then after that, what is the next velocity of jet V is equal to 20 meters per second. And what is the velocity of the plate U is equal to 5 meters per second. This is the data that is given. So now our first problem is, what is the force? Force is equal to rho A into V minus U whole square, because the plate is vertical and it is moving, but it is a single plate. So rho is 1000 kg per meter cube per water. Then A is equal to 0.001963. That is basically A, and it is V is equal to 20 minus U is equal to 5. V minus U whole square divide, that's all. Then in such a case, if I calculate this, I got the answer 441.78. So as the plate is kept vertical, naturally the force applied is, which is the equal to, force is equal to Fx. So therefore the second answer for your thing is, what is the work done? The work done is nothing but Fx into U, that is equal to 441.78 into U is 5. So that is equal to 2208.9 Newton meter per second, because Newton is the, this is Fx is in newtons, this is in newtons, and this is in meters per second. So that's what I have written. And this Newton meter per second is also nothing but, it is in terms of watt when you calculate the power. So directly I can say that it is equal to, if somebody asks me what is the power, power is equal to 2208.9 watts actually. So this is equivalent to watts actually. What is the third thing that which I have to take? The third thing is, what is the efficiency of jet? Just now I explained the efficiency of jet eta is equal to, it is nothing but output by input. Input is always from the nozzle which is coming. So therefore output is equal to, always it is the work done. It is work done divided by kinetic energy of jet. It is no way related to whether the plate is moving or fixed. Jet is leaving from the nozzle. There, what is the energy? So it is equal to Fx into U divided by, which we calculated already. It is half into rho AV into V square. So already this is 2208.9. Already we have calculated. Let us calculate this also. Half into rho is 1000. A is equal to 0.001963 into V. It is V is 20 square into 20. So if you calculate all that, you are going to get, how much you are going to get? 0.3377, which is nothing but equivalent to, into, in terms of efficiency percentage, into 100, if you put 33.77 This is what. Let me take another problem in this. A 7.5 centimeter diameter jet having a velocity 30 meters per second strikes a flat plate, the normal of which is inclined at 45 degrees to the axis of jet. Find the normal pressure on the plate when the plate is stationary and when the plate is moving with a velocity of 15 meters per second and away from the jet. Also determine the power and efficiency of jet when the plate is moving. The same problem he asked when the plate is stationary, one question, and when the plate is moving. But this is a question of inclined plate that you should remember first. An inclined plate question he has given, and in the inclined plate question he has given, if you keep the plate stationary, what is the normal force? And when the plate is moving with a velocity, the x what is the force and what is the power, what is the efficiency. Now let us keep the first question. Plate is stationary. Plate is stationary, you know it. Fn is equal to, because he asked normal force only, rho a into v square into sine theta. When the plate is stationary, u does not come into picture. So it is rho a v square sine theta. Rho is equal to 1000. A is equal to diameter. How much has given? 7.5 centimeters. So if I take it, 7.5 into 10 to the power of minus 2. The reason being it is in centimeters. Rho a pi d square by 4, right? Into V is equal to, he has given how much? 30. So 30 square. And sine theta is equal to sine 45 degrees. So if you evaluate this question, once again, just see how I am writing also all the things. So if you do it, that you are going to get 2810.96 newtons. So this is the first question he asked. Then what is the second question he asked? Plate is moving. plate is moving, then what is Fn is equal to? Fn is equal to rho A into V minus U whole square into sine theta. Then what is Fx is equal to? Because Fx is equal to Fn into sine theta. Therefore, if I calculate the same thing, first I will calculate what is Fn. Fn is equal to rho A into rho is 1000, right? Then A is pi by 4. It is 7.5 into 10 to the power of minus 2. Please, sometimes I am putting minus 3, sometimes I am putting minus 2. The reason being the unit actually. If it is in centimeters, I have put this. It is in millimeters, I put 3. Pi d squared by 4 into V minus U. V is equal to how much he has given actually? 30. And what is U he has given? U is 15. It is whole square into sine 45 degrees. See, anywhere you are having any difficulty. So then in such a case, we get actually if this Fn is equal to 702.4 newtons. Please check the answers. I may be doing something basically fast, but kindly check that answers also. So once Fn is over, then you need to calculate what is Fx. Fx is equal to Fn sine theta. Please remember that. Because for work done and all, we use only Fx, not Fn. Therefore, what is the next question he asked? What is the work done? Work done is equal to, it is equal to Fx into U. Fx, how much you will get? It is nothing but Fn sine theta into U. And Fn is what? 702.4 into sine 45 degrees into U is how much? 15 he has given. So if you calculate that, you are going to get actually this is equal to 7,453.5 Newton meter per second, because force is in newtons, this is in meters per second. Then what is power? Power is equal to work done by 1000. Why I am putting is to convert into kilowatts. This Newton meter per second is nothing but watts. So it is 7,453.5 divided by 1000. So it is equal to, you are going to get 7.4535 kilowatts. If you want to keep in watts only, just replace this Newton per second divide watts. Plus, then the moment you write power, it becomes watts, it becomes power. The moment you write Newton meter per second, it becomes work done per second. Right? If you write this unit, it becomes this. If the same thing you write what, it becomes this. Then next question he asked there is what is efficiency? Efficiency is nothing but work done per second divided by basically KE of jet. Work done per second is how much? 7,453.5 divided by half into M is rho AV into V square. So it is equal to, if you calculate, 7,453.5 divided by half into rho AV means 1000 into A is 5 by 4 into 7.5 into 10 to the power of minus 2 whole square into V is 30 into 30 square. So if you calculate this all, you are going to get 0.125. So that is nothing but actually 12.5% in terms of percentage. So this is the second problem which I have done. One is stationary. One is a moving vertical plate, the second inclined plate. But there I try to compare when the plate is stationary and when the plate is moving. So please see that. Then third, I will take it up the vane problem. So the vane problem, if I take as the third, a jet of water of diameter 7.5 centimeters strikes a curved plate at its center with a velocity of 20 meters per second. The curved plate is moving with a velocity of 8 meters per second in the direction of jet. The jet is deflected. The jet is deflected to an angle of 165 degrees, assuming the plate smooth. Find force exerted on the plate in the direction of jet. Power of the jet, efficiency of jet. So these are the things. So if such is the question, let us see. So they have given you diameter 7.5 centimeters. So therefore A is equal to pi by 4 into d square is equal to pi by 4 into d is equal to how much? 7.5 into 10 to the power of minus 2 because in centimeter square. So it is equal to A is equal to 0.004417 meters square. Then V is equal to how much they have given? 20 meters per second. Then what is U is equal to? This is 8 meters per second. Then deflection angle is equal to 165 degrees. Deflection angle means it is always 180 minus theta. Therefore, theta is equal to 15 degrees. I will show the figure also for better understanding. Suppose this is the plate The jet is striking here. Then this is the direction of movement of the plate. So naturally the jet gets deflected. The jet after striking the plate, it leaves like this. This angle is deflection angle. It is equal to 180 minus theta. So what is this angle? Theta. So now if I want to calculate, this is V. So this is theta. So that theta is 15. So now we already know the entire things. What is Fx is equal to? Already I explained rho A into V minus U whole square into 1 plus cos theta. So rho is 1000. A is equal to 0.004417 into V is equal to 20 minus U is equal to 8 whole square 1 plus cos 15. It is equal to Fx is equal to, if I calculate, it is 1250.38 newtons. First answer. Then work done per second is equal to Fx into U. So it is 1250.38 into U is 8. So it is equal to how much? It is 1000, 10,003.04 Newton meter per second, because this is Newton, this is meters per second, and therefore power is equal to. I just told that remove this Newton meter per second and put watts. Bus by 1000, if you put it, you get in kilowatts. If I put it approximately 10 kilowatts. If you don't want to write in kilowatts, directly you can represent the number. Watts to kilowatts is by 1000 I have. Okay. Then next last question in that is what is efficiency? Efficiency is output. This is the way you should write input. Output is what? It is work done per second. Then what is input? KE of jet. So it is Fx into U divided by half into rho AV into V square. Then if you substitute each of the things, you get 0.564, which is equal to 56.4%. I did not submit here anything because Fx into U is this is nothing but this straight, and rho AV is 1000 into A. You can already point 00. We have done it already. V is equal to, you know it, rho AV square here, and here there is no of MV square. Sorry, of rho AV into V square. 1 second. Mass is rho AV, total mass into V square. Fine. So V is equal to 20, A is equal to known, rho is 1000. Substitute it, you get this answer. So three types of problems I have solved. One is a fixed plate moving, one is inclined plate moving, third one is the curved plate jet striking at the center, it is moving. These three I solved in this class. So in the next class, we solve some more problems because here you should be very careful. That's why I'm not solving many problems in the first one lecture itself, so that slowly you can understand each after the other how we are solving the problems. So each class I am solving two problems or three problems only, so that you understand and practice it more after going over there. There will not be any extra problem that you need to really work at home. Only thing is continuously you sit by the side of me, and then as per whatever I am telling, work in the calculator, use the calculator and calculate the things and then go. On each model you do one more problem. So that's why I am not doing more problems in each class, only limited problems to make you to better understand this. So in the next class, again some more variety, whatever we have left up now, that we will take it up.
Like, share, and subscribe. Hit the bell icon for more updates.